Exercise 21.5, question 6. So in this question, we have a projectile projected from a point O, which is the origin, and it passes through a point P on its trajectile. So let's have P as being here. But what we also know is that it is travelling horizontally when it passes through this point. So that is the same as saying that that is the maximum point that the projectile reaches. And what we are given is we're giving that P is 1612. And what we're asked to find is the angle of projection and the magnitude of the initial velocity. So really what we want to find is we want to find the vector u here. And if we can find this vector u and we can find its components, we can find the magnitude of u, which is going to be the initial velocity, the magnitude of the initial velocity, which is the initial speed, and we can also find this angle here. Okay, so let's think about what we know. We know at this point P, we know the displacement r is equal to 16 and 12. We know the acceleration, which is constant, and it's only due to gravity, so it's 0 and minus g. And what we don't know is the initial velocity u, but if we split this into components, we know that the horizontal component of this is u cos theta, and the vertical component is u sine theta. Okay, well what we need to do now is put this into the Suval equation, r equals ut plus a half a t squared. So we get 1612 equals u cos theta, u sine theta times by t plus a half of 0 minus g t squared. And if we read off the horizontal and vertical components of this, we get 16 equals ut cos theta, and we get 12 equals ut sine theta minus g over 2 t squared. But the problem with this is we have three unknowns. We have u, t, and theta, and we only have two equations, so we need to get some more equations from somewhere. Well, we're going to use the fact that P is the maximum point. So at that point there, it only has velocity in the horizontal direction. So if we take the velocity at P to be v, what we know here is we know that actually the horizontal component of velocity is still u cos theta, because there is no force acting horizontally, so it remains constant. And we know that the vertical component of velocity is 0. So if we use the Suval equation, v equals u plus a t, we will get u cos theta and 0 equals u cos theta u sine theta plus 0 minus g t. And that top line of that doesn't tell us anything interesting at all, but the bottom line does. It tells us that 0 equals u sine theta minus gt, and rearranging that for t, we get t equals u sine theta over g. Okay, well that's the third equation we want. So we've got equation here, 1, 2, and 3. 3 equations and 3 unknowns. And we want to eliminate t from these. So I'm going to substitute equation 3 into both equations 1 and 2. So 3 into 1, let's do this in a different colour. We get 16 equals u times by t. Well, that is times by u sine theta over g times by cos theta, which is actually u squared sine theta cos theta over g. And if we put 3 into 2, we get 12 equals u times by t. So u times by u sine theta over g. So u squared sine theta over g, but times by another sine theta, so sine squared. Minus g over 2 times by u sine theta over g all squared. Let's do a little bit of simplifying on that. We get 12 equals u squared sine squared theta minus g over 2 u squared sine squared theta over g squared. So cancelling a factor of g here, we actually get u squared sine squared theta minus a half of u squared sine squared theta. So that is actually a half of u squared sine squared theta equals 12. And actually it might be sensible to multiply that through by 2. So 24 equals u squared sine squared theta. Okay, so let's label these two equations. We are missing a g, sorry, there is a g here. So that is over 2g, so that is 24g. So let's label this equation 4. Let's label this equation here equation 5. Okay, and what we want to do now is we want to divide 4 by 5, and why we want to do that will become obvious when we do it. So dividing equation 4 by equation 5, we get u squared sine squared theta divided by u squared sine theta cos theta equals 24g over, and it's actually something I haven't done here. Really what we meant to have here is u squared sine theta cos theta equals 16g, so multiplying 3 by g equals 24. So this equation here, the 4 divided by 5 becomes 24g divided by 16g, which is actually 3 over 2. But if we start simplifying this here, our factor of u squareds cancel, and a factor of sine theta cancels, so we get sine theta over cos theta. So what we get is that sine theta over cos theta, which is tan theta, equals 3 over 2. So theta is tan inverse of 3 over 2, and it's going to be the principal value of that because we know theta is an acute angle, and that's whatever that is going to be the angle of projection. Okay, we've not quite finished because we also now need to find u. So what do we know about u? Well, if we take equation 4, we know that u squared, from equation 4, we know that u squared equals 24g divided by sine squared theta. So u, and u is positive, is root 24g over sine theta. Well, we can work out sine theta exactly, because if we take a right angle triangle with an angle of theta here, and we know that the tan of the angle is 3 over 2, so we can consider the opposite being 3 and the adjacent being 2. By Pythagoras' theorem, the length of the hypotenuse is the square root of 3 squared plus 2 squared, which is root 13. So what is sine theta? Well, sine theta is the opposite of the hypotenuse, so that is 3 over root 13. So putting that in here, we get u equals root 24g over 3 over root 13. then multiplying through by root 13 on both sides, on top and bottom, we get that u is equal to root 24g, root 13, all over 3, which is approximately 18.4 meters per second. So we know that the initial speed is about 18.4 meters per second, and it is an angle of theta equals tan inverse of 3/2.